Okay, so good morning. So far, the new version of OBS has bugs. Doesn't, yeah, so like my tip jar disappeared. It's just like, if I switch scenes, it resets configuration. So now I'm gonna have to go back to whatever the old version was. You know, I know it's volunteer software, so I try not to be too hard on it, but I guess that's just the point. It's volunteer software, you know. There's no rush. If a release isn't ready, don't ship it. Hey, move. Okay, today is Wednesday, the 22nd of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, and I stream it here on Twitch Monday through Friday. I am working on Basecode, which is a new programming language that I am designing. Specifically, I'm working on the Bootstrap compiler, which is written in C++ 17. And yesterday, I got the first pass on the cast operator, fixed a bunch of bugs in the interpreter and some compiler issues. So that's looking good. I started work on the new constant assignment operator. I got rid of the constant and alias statements in the language. So those are gone, and the plumbing is more or less in place for the constant assignment operator. Wrong tool. Come, you can do it. All right, we'll do it this way. Right, so the assignment operator is an infix parser because the nature of how it works. So the constant assignment will be also and what I'm going to do is refactor so that both of these use more or less the same code. Okay. Excuse me. Hey, Everex. Hey, Slayer Darth. Uh-oh. What you got for me this time? Super circuits. I noticed I had changed some of these, but not all of them. Consistency is hard. Hey, super circuits. How goes the sound hardware programming super circuits? I'll tell you. So maybe you intended to indirectly trigger me. I'll tell you what I think it is with math. I think, so I have a brother, two actually, but one of them specifically went to university specifically for math. And it's interesting to listen to him talk because he'll say things like arithmetic isn't math. And technically, I guess he's right. If at that level you view math purely as high-level symbolic abstraction. So in a way, somewhat similar to programming. But here's what I can tell you I think the issue is with math and why we all suck at it. Or why a lot of people suck at it. It's the way it's taught, right? And it's not, I don't even think you need to have practical examples per se, although those would help. The issue with math is that here's how math works. Math, you have a math book, right? And have you ever noticed that if you read a math textbook, that it assumes, they always assume that you know everything they're talking about. And so if I were to just pick up a math book, its math courseware is not designed, at least from my perspective, to be taught non-sequentially, non-linearly. And math makes this, I think, rather faulty assumption that everybody memorizes all of the minutia. Everybody memorizes all of the details. Like, I remember studying geometry. I remember writing proofs. I can't remember any of the proofs. I understand conceptually what has to happen to write a proof now. I know what they are. I understand the logical progression that one would take, but I don't remember all the rules. I don't remember all the details. Now, so this is the problem with math, is that mathematicians or people who are naturally have a bent towards math, and I would argue these are folks that just have really good memories, they remember all of this stuff. And so when they're introduced to something new, they remember that all these different rules that apply from their history of being exposed to the math. Here's the secret. Here's the dirty secret. I would argue that the majority of the population on the planet struggles with that sort of learning process, right? They just don't remember all the details, or they remember the details long enough to pass the test, and then they forget them. And it's not even an issue of whether or not math has practical utilization. Of course it does. The question is, how can we alter the curriculum in such a way that it doesn't favor people like my brother, who it's just in his head, right? I mean, this kid could do math with his eyes closed and half asleep when he was like 8 years old. I suck at math. Why do I suck at math? Because I can't memorize things. I can't memorize small, anonymous things. They're very difficult for me to memorize. And math is just this huge compendium of, if you didn't memorize this, and 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 this, then the next thing that you're about to attempt, you're going to fail, right? Because that next new concept that they're introducing it under the assumption that you've memorized these 3,000 other things. And yeah, people have a hard time with that. I mean, in a way, if you think about that, that's like learning a foreign language, but a foreign language that you never speak. Never, unless you're in math, right? Unless you're doing it every day, you're going to lose that. You're going to lose all that history, all those little rules, all those little layerings that they go through so much effort to blandly explain to people. Is it any wonder that we all suck at math? I don't think it's that surprising. And even arithmetic. I mean, we're just talking about memorizing multiplication up to 12s and addition and subtraction. And here's weird things like, see, I've had to hack myself over the years to work around the fact that I have a hard time learning math. Not doing math per se, just memorizing it. And perfect case in point, you know, this morning I went to McDonald's to get coffee, and the guy, early in the morning here, they don't have their computers on because they're doing their books, so they do everything by hand. Well, he was lost. Like, he couldn't figure out the change on his own. The only reason I could do it in my head was because I taught myself, I'd found a way to work around the deficits of my brain, essentially. I couldn't cram the math as a memorization thing. I had to come up with a procedure that I could follow repetitively and something that I would remember. But that's, to me, that's what's missing, right? And the problem is that all of the math proponents are I hesitate to use the word gifted, but they have a propensity towards math, and that's great, right? But not dissing that at all. I'm saying that those people have a blind spot when it comes to teaching the rest of us, and let's face it, that split is probably like 80-20 if I'm being really, really, you know, generous, right? In other words, about 20% of the population, they're just the way their their brains work, and it's probably genetic, right? They're able to memorize and access these kinds of very vague, high-level, anonymous facts and regurgitate them, right, very quickly. The other 80% can't do that. Wiesen 3000, I've talked about this before. People, and again, I don't blame people for this too much because we have a lot of media that repeats things that are bullshit and it just becomes part of the gestalt, right? It just becomes part of the group mind. And somewhere in the 70s or 80s, or I don't even know when, right? Those in the position of no, they didn't really understand what programming was or how people would even use it. So, like most folks in academics, and this is a slight ding here, they say, oh, well, all the kids that are really good at math, they're smart, right? And just let that sink in for a second. But this is not, okay. How do I even explain this? This is not math. No, it's not that you're trolling me. This is a common misconception, in my opinion, right? Do you know how many computer science or math books I read about ASTs? 0. Do you know how I learned about ASTs? By building them, right? How does somebody who builds a house learn about building a house? By reading blueprints abstractly and solving calculations abstractly about the blueprints? Oh, there's exactly 24 inches from the edge of this stud to the beginning of the next stud. Okay, so now let's calculate. No, 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 no. No. Again, you probably like math. Perfect. You're a book guy. You're a math guy. I get it. But what I'm trying to get across here is that there are very few of you, percentage-wise, right? And that's a great thing. You know, you've got a skill set nobody else has. So my point is that the way in which I write code using these concepts it bears almost no resemblance to how math is taught to people. And when people talk about math, I mean, everybody uses math every day, right? But it's the way in which the concepts are conveyed that is the issue. But here's the other thing that I would say, now that I'm on the topic, and I just realized that my obsessive compulsive habit, you know, made something seem important here. I think one of the other issues that we struggle with, especially like in, you know, I'll use computer science here as an example, or programming. I won't even go to computer science because computer science doesn't necessarily imply programmer. But we have this tendency to want math to explain everything, right? And that if math explains everything, then that's sufficient enough. And it's not, right? Because programming is not pure yet, right? Maybe it will be in 100 years. Maybe programming will just be the definition of facts and equations, and then the machine behind the scenes will figure out all this nasty stuff that humans used to have to do by hand. We're not there yet, right? I don't know if we'll ever be there. We're not there now. And so writing software specifically is a craft, right? It's a skill. And some of the things that you do in software have absolutely nothing to do with math, right? There is no mathematical reason why I go through and try to make my code look readable and presentable. There's nothing in computer science that can explain that, right? That's an engineering discipline. That's a skill thing, right? That's something that you either learn to do. Okay, but again, you're obviously a math guy, right? And this is my point. This is my argument. Of course, yes, right. But you're missing it, right? This is why the math guys and guys like me have friction, right? Because to you, everything's math, it's all symmetry, it's all structure, it's all beautiful, wonderful. But for the majority, they don't see it that way. There's other, you know, hooks that they have to hang their mental thoughts on. And some things like code cleanliness and structure, those are difficult. If your brain does not fit in the math box, trying to get people to think of everything through that lens is counterproductive. That's my only point, is that yes, of course, everything ultimately boils down to some, wonderfully beautiful, discrete mathematical something or other. We don't know what that is yet for the entire universe, but it probably does, right? Wolfram seems to think it's, cellular automata, whatever it is doesn't matter. The fact that that's true, the fact that we are all atoms, and then underneath that we're all subatomic particles, if I go to you and I start talking about my atoms and my subatomic particles, it's meaningless, right? For the average person, it just doesn't do enough. There isn't enough there. I'm not saying that if you understand all the math that you can't grok the beauty and you have a little bit of secret understanding that the rest of the world doesn't, or the majority of the world doesn't, but it's not a practical foundation, in my opinion. Now, maybe in 300 years, when we're living in something akin to, the United Federation of Planets, and every human has, 40 or 50 years because lifespans triple, and they don't have to worry about making money, and they can spend all their time, in their childhood, learning all this stuff, and, obviously we could assume we get better at teaching it, then maybe humanity of that future will see everything much more plainly and will see the underpinnings so cleanly, but we're not there yet. That's not to say you can't strive, but and it's, I see look, programmers are like this, right? We have a hammer, it's called software, everything is a nail, and that nail needs to be pounded with software. People who like math, or they're very steeped in math, they see everything as math, and that's great, that's fine. But, I would argue that if, out of 100%, what? Probably 30%, maybe, understand software on some level. Then they, I would say half that truly has an affinity, truly groks and can use math on a level like that. But again, these are words, right? This is not Boolean algebra. This is not true false. This is my point. We're human beings that have sloppy meat computers in our skull, and we don't accurately convey information verbally. We don't accurately convey information in a written form. We don't have perfect nomenclature for these things. So I don't have the right description to talk about people who think about the world as math, other than to say they are math people. And then the people who don't think about the world as math, as non-math people. I don't have any better nomenclature for that right now. And, this is not meant as an identity statement. This is meant as describing a trait or attribute that I have run into over my career, and I'm sure many people have. There are people, and I would say a couple of you fit that bill, and this is not negative. It's not negative, it's just the way you are. That's fine. I'm the opposite, right? My brother would say the same thing as you say, right? Numbers are natural. Numbers are part of reality. This and that. And in his brain, it just fits, right? But yes, it is fully discoverable by play. That is true. And I would say that the level to which I've been able to master some very small percentage of mathematics, the only way I've been able to do that has been to actually play with math on my own terms. So yes, that's absolutely true. And I'm not saying it's mythical. I'm saying it's a mindset. I'm saying it's a way that people approach the problem, right? That's what I'm talking about. Just because I recognize, so what you're basically, saying, and again, I'll use the atomic structure, quantum structure example, analogy. What you're saying is fundamentally everything is math, and math is not mythical, it's part of reality, and that we can all learn it. I point, you win. That's absolutely 100% true. We're also all quantum mechanics, and quantum mechanics isn't mythical. If you spent time, everybody could learn that. But where I'm going with it is that all I'm saying is that there's a group of people, and this is not a negative attribute, this is a gift, that are able to subsume the understanding of those concepts to such a degree that they can just fold that understanding into their day-to-day operation. However, my contention, and perhaps I'm wrong, right? But I don't think so. My contention is that the percentage of the population that can do that naturally, without massive amounts of time investment and effort, and they still probably would not approach the native understanding that someone who is gifted in this area, right? It's not practical for them to, yes, you can acknowledge that the numbers are everywhere and it's, they're natural and it's reality. And why can't you just get it? But it doesn't, that part doesn't just work. It's kind of screwy, right, in a sense, because if numbers are everywhere, we're made of numbers, you would think we'd intuitively understand them. But while that's true for some, I don't think it's true for everyone. So it's that differential in effort, right? How much effort do you have to put in to get to some level of competence in understanding that stuff? And there's a lot in math, right? It's not just one thing, it's many things. So, then it starts to get sloppy, right? Then it starts to get human. Okay, well, I need to do linear algebra because I want to write games. Okay, so I will invest lots and lots of time in linear algebra. But if somebody asks me about calculus, done. Don't have it, right? Because I didn't invest the time in that because that wasn't practical. Here's the math versus code mindset. Here's an example that I would pull out. I feel kind of bad because he's not here today. But Lemmy, what's his name? Lemmy Leet? Or, yeah, something like that. That's his handle. Their handle. Don't know the gender really. And that they obviously love pure type theory. I mean, it's very clear that they have a very mathematical bent to approaching things, which is great, and it's wonderful. And there are languages that move towards pure type theory. There's trade-offs, nothing's perfect. But there's a reason why languages like that I would contend, have not reached, mass appeal. Because in order to work in that world, you have to have already sort of integrated those notions into how you approach things. So that's one example, right? Where someone would be kind of drawn toward like a Scala versus something else because that feels more mathematically pure to them. C and C++, not mathematically pure. And some of that is just deficits in, language design and legacy and all sorts of other stuff. But whenever you have a conversation with a programmer and they start talking about the coherence and concreteness of the type system, you kind of, I don't know, I've just sort of over the years, I guess I've had a lot of conversations in that direction. But it's like, oh, okay, this person is thinking about this like they would for their math assignment. Okay. What was I doing? Oh, right. Okay, so I have two assignment parsers. One that handles the regular assignment operator, and one that handles the constant. Oh, I'm sorry. Emmy Singer? Not sure. It looks like they might not be around still. How do you advise learning C++? Yeah, I mean, in general, my advice for learning programming is kind of always the same. First off, if you haven't learned anything yet, then I always kind of advise to start with assembly language, especially if your goal is to get into lower level development. I would not, again, these are just my opinions. I don't have any papers or proof or anything about why this I think is better. But if you want to learn C and C++, I would not start with C++. It's going to confuse you. There's a lot of extra, again, it's like anything. It's very similar to the math thing I just described. You have to kind of start with some fundamentals. And if you're going to do a lot of low-level programming, or you're going to be programming in an environment like C or C++, where you're close to the machine, then it's beneficial to understand the machine. Now, you don't have to be an expert at it, but having some exposure to how a CPU works, how memory works, how memory mapping works, and all that good stuff it's going to be all good things for you. Then when you move into C and C++, those are going to give you a good fundamental backstop about what the machine is and what it does, how it works. So I always recommend, I think I still have here, it's under Learn. So you can pick one of these. There are 3 emulators here, one for a MIPS CPU, one for 68,000, and one that does x86. The nice thing about these tools is that they're all in one. You can download the tool, and you don't need anything else. You just do all your work inside of the emulator. You don't have to worry about setting up compilers or makefiles or CMake or any of that nonsense. So it lets you just focus directly in on learning about a CPU. Now, again, people have varying opinions. Mine is it doesn't really matter what CPU you use to learn. Because while the assembly language and the instruction encoding and the endianness and all sorts of other things might be different, it doesn't really matter. The concepts are largely the same from CPU to CPU. So pick one, and then, like I always advise, pick a very small project, something you want to build. I typically recommend games because people tend to be more motivated by building simple games, and secretly every programmer wants to be a game programmer. So, you don't have to do that. You can work on any kind of problem you want, but I'm going to use games as an example. So let's say that you pick Easy 68K, and what I would suggest is you pick a game like the Snake game, or yesterday I was watching Jessica Mack, and she thought Pong would be difficult because of the physics. I don't know that it needs to be that complicated. But like Snake, Pong, Breakout, Tetris, I've mentioned Pitfall, reproduce Pitfall. You don't have to do all those, pick one. And yeah, Hangman, there's a ton of them, right? And pick one, and every day set aside some fixed amount of time. I would say that 30 minutes is probably the minimum that you would want to dedicate. An hour is probably optimal for learning purposes, because you don't want to burn yourself out. You don't want to burn out the circuits, so to speak, while you're doing it. But again, the amount of time you put in is entirely up to you, but I would say minimally 30 minutes every day. And I personally think that it's important to pick the same time every day. So set aside a block, same time, same environment, if you can manage that, every day, and work on this problem in one of these tools. And your goal is to build to whatever it is that you're trying to build. And I'm going to warn you ahead of time. You're going to have stumbles, you're going to have challenges, you're going to want to throw things at the machine, you're going to want to throw the machine out the window. Those are good signs. That's what you should be experiencing. And if you put the time in and you work diligently towards building one of these, put an upper bound on it, 30 days, see how you do. How far did you get? What problems did you have? If you completed it, then you can move on to, the next step. Once you've done some work in assembly and you've kind of gotten that experience of how the machine really truly works under the covers, there's no magic, there's no bullshit. That's what the machine does, right? Then you can move on to C. Don't move on to C++ yet, because that's just extra stuff that is confusing in the beginning. Reproduce the same thing that you built in one of these tools in C. That's going to be more complex, because now all of a sudden you're using a real compiler in the operating system. You're going to need makefiles, you're going to need third-party dependencies, you're going to need lots of stuff, right? And so you're going to learn a whole bunch of new things, right? But fundamentally, the game, what you built in assembly language, and those fundamentals are still the same, right? Nothing's changed. What's changing is the environment and the tools. And that you're going to learn about that as you go through that process, and that's a necessary step that you need to go through. It's a painful step, and I would say setting up environments and builds, and especially cross-platform builds, to this day is probably my least favorite activity. So then spend another 30 days with C and rebuild that same game. You can change projects if you want, but since you've already successfully built one in assembly language, I think you learn more by retreading that project, in the new language. Because then you're not spending a lot of time thinking about the project so much as you are, okay, how do I express this in this new language? How do I use this new language to its, maximum extent? Then, if you complete that, then you can move on to C++. At this point, C++, the difference between the ++ part and the C part are templates, the standard library, standard template library, and the OO parts, which I would be very careful how much you dive into the OO stuff, but yeah, then you can explore the differences. What does C++ give you? What new abstractions are there? And again, I would explore the same problem again, and okay, how could I rewrite this using the new things that C++ gives me to make it shorter, easier to work with, so on and so forth. Magnum Baguette says, hey, I just came in. Are you asking us to start learning from assembly? Yes. Other way around. I'm not sure. Like you would learn what? Lisp first, and then you would learn assembly language last. I don't know. No, I mean, I come from the old school, and yeah, no, I would go the other way, because again, look, I know this is controversial when I say this. High level is an illusion. It does not exist, right? I am building a quasi-high level language. It is an illusion, right? That's not what the machine does. That's not what the machine is. Now, I'm not saying that it's practical every day. I'm not telling you to go tell your boss, hey boss, this guy on the internet said we should rewrite everything in assembly. It's not what I'm saying. What I am saying is that if you're trying to learn, then you should understand what the machine does. You should understand what the machine can and can't do. And and the easiest way to do that, short of going and taking an electrical engineering course, would be to study assembly, right? Now, my purpose there, again, is so that you have some understanding of what the machine is doing. Once you have that understanding, for most practical purposes, you're fine. You can start moving on and doing other things. What it will do, though, or what my hope is, that by learning things that way, when you one day are writing some uber high-level JavaScript nonsense, and somebody says to you, oh, we can't do that. That's way too low level. You're going to chuckle, and you're going to say, no, it's not, because you're going to understand what that means. You're going to understand what the machine can do. And it's not, I run into so many developers nowadays that started in these very high level languages, and they walk around believing in mythology, right? They walk around thinking that the machine does things it doesn't do, and that's dangerous, right? So that's why I suggest starting from the bottom and going up. Yeah. Anonymous has a pretty good summary of how things tend to happen. But yeah, so Igloo Kid says there are many pitfalls and dragons moving from C to C++. I completely agree. I would not suggest people start with C++, right? Don't start there. That's not. It sounds maybe elitist or condescending, but you're not ready for it. If you know, you're not ready for it. It's like going to a Jedi, Padawan, and saying, "Here's this really cool triple-bladed lightsaber," and then the Padawan cuts himself in half. Right? They're not ready for it. And the ready part is exactly like what Igloo Kid said. You have to rationally be able to say, one sec, which parts of C++ are useful and which parts are not. And that takes experience, that takes some exposure, right? And if you build something in assembly, then you build it in C, then you go to C++, you're going to realize, okay, I know what this looked like in C, so you're going to have this good picture in your head, or you should have a good picture in your head, to where you understand the changes you're making, and do you like, does that work? Does that make sense? Are you happy with the result? If you just jump into C++ as like another one of the OO languages like Java and C# and whatever, that's dangerous. Yeah, Pico 8 is cool. I like Pico 8. So Magnum Baguette says, where do I find documentation on assembly? I mean, that is one of the downsides there. I would recommend, your absolute best bet is finding like actual dead tree books about the topic. This is one of those areas where there's lots of information on the internet, but it's very dispersed and not well organized. Once you have more experience, it'll be easier for you to pick stuff up. But Peter Norton had a series of books back in the 80s and the 90s that were very good. You could find those on Amazon. If you search, generally speaking, that are good, would be good books. And again, the CPU doesn't really matter so much. It's going through the effort of using a CPU and actually building something with it. I've done some C++, but don't have the time outside work in my own projects for anything full featured yet. Contrary to when you first started, there are so many open source C++ projects whose source code one can read. Sure, but you can read C++. What if you can't, right? I mean, that's the key, right? Is I'm sure there are wonderful, awesome novels written in Russian. I can't read Russian, right? So how can I appreciate it? So I'd first have to learn to read Russian. So yes, if you're already a C++ programmer or you're a C programmer that has had some exposure to C++, you've already kind of been through those formative cycles, then yeah, reading other people's code is a great way to learn. And I mean, technically anybody could do that, and anybody could go out and read tons of source code, just picking a language to start with. My argument there, though, is, as always, there's a lot of stuff you won't understand. You just won't have the underpinnings for it. So even if you spend a bunch of time reading C++ and you become familiar with the syntax, there are going to be these things like, what do pointers really do? What is, there's going to be all these concepts that are going to seem very confusing still. And that's what I want to try to help people avoid. I have recommended C++ Annotations by Frank Brocken as a book that takes a very wise approach to C++. Yeah, I haven't read it, but yeah, I'll take a look at that one. That'd be cool. All the Russian you need to know is vodka and comrade. Yeah. Have you seen the open source CPU? If I have, I don't remember it, which is not very uncommon for me. So I probably have seen it at some point. I just have forgotten about it. Okay, so I added the token for constant assignment to our infix parser list. So we have two parsers, one for the mutable assignment. Oops, easier, there we go. One for the mutable assignment. This calls create assignment node passing in, or I'm sorry, this is the immutable one. This is constant. This passes in the constant assignment type. The precedence is assignment, because really what's going to happen is these two different kinds of assignment get consolidated down in the compiler. It's just a flag that gets set. And then we have the mutable one that passes in the assignment type, same precedence level, and on the parser, I think that's it. So then the last step for this, I believe, is we're going to vector, there's an old-fashioned term, both the assignment and constant assignment AST nodes to the one conversion function that I already have for assignment. And then we're going to just change that function slightly to say, okay, is this a constant assignment? If it is, okay, set the symbol to be constant. And then we just have to add an error check. We have to add a new condition check that if you are trying to redefine something that has been defined as constant, you can't do that. So let's make sure I haven't broken anything. Okay, looks good. All right, so let's go to AST evaluator, and so here's assignment. We're going to add constant assignment. This is one of the nice things about doing this lookup table like this versus the switch statement. I mean, in the switch statement, we'd have to refactor it into a function and then have the different cases call the same function. Yeah, so assignment and constant assignment are going to call the assignment evaluator function. And that in turn just calls add assignments to scope, because I did this as part of the consolidation effort. So then in here, the AST node that we're getting is, I'm going to say bool is constant assignment, and we can say node type is equal to syntax AST node types constant assignment. Okay. So here, we set the constant flag on the symbol based on that. And everything else we have in the compiler that was working on that constant statement, that's all still there. We just are changing how we set the flag. Okay, well, let's see. Peter Norton assembly language. Yep, this is the one. It's so funny how you have images in your head. This was from 1986. Now, this is for the IBM PC, so x86. But, you know, this was a good book. I remember having this book. And you can see there's a whole ton of other books here. Now, you can't get to Amazon. I don't know if there's a way around that. But here is the title. You can, if whatever mechanisms you have available in your country for, like if you have libraries or whatever. Let's see. This is an old book though, and a lot of the books that I would recommend are older. But that gives you an example. You could use DOSBox for the Peter Norton thing, or you could use VirtualBox. There's a variety of different ways you could do that. One of the emulators that I have in my list, that very first one, that's for the old-fashioned x86, CPUs. So you could probably use that for a good portion of what, the Peter Norton book shows you. His stuff, he starts with MS-DOS and uses that because that was the thing at the time. So I'm sure this is a great book. I don't know if I remember reading this one or not. Oh yeah, Linux would be very different. Because the way that you interact with the operating system is different. Honestly, I don't have any experience with these, so I don't know. But this one is specifically for so that one's more geared towards Linux. Okay, so there's one other condition here that we have to account for, and that is if it's constant and we fall into this case, that's an error. Okay, so if we fall into the case where we need to generate, this is the scenario where we would actually generate a real binary operator that would, it's code that actually running versus pre-collecting initialization data. Now technically, I think add identifier to scope also has that same condition. So the check is a little different, and the error itself is a little different too in this scenario. So if we fall in here, and if, was it a symbol, is constant, it is, they're different modes. Intel CPUs are, I mean, Intel isn't alone in this. ARM has some legacy now too, but more modern CPUs have legacy, right? They have stuff they supported 30 years ago, and then they have stuff now. And a lot of these CPUs, they have different modes of operation. So the answer is yes, these modern CPUs support the old stuff, but you have to put the CPU into the correct mode to support that. Okay, so I think that covers both air conditions. Okay, so let's test what we have, which is just testing the standard assignment. That should continue to work without any issue. And it does. Good, good. All right, so let's open up our test file, and let's make E a constant. So this should be fine. This should compile without error, but E is a constant value now. Hey. See? Did myself in. So we only try to get an element if we succeeded. This, actually, I just realized this. This is an interesting condition here. We're going to get an error. Ooh, not the error I expected. Oh, here we go. Well, this is the error expected. Constant variables require constant expressions. So now I'm wondering if I actually want to catch that particular case. The AST errors, I think those are because I'm, excuse me. No? Okay. Where's that error? AST node evaluation. Yeah. Do I really? I don't need to add that, do I? Actually, let's move that error. It's in a kind of a weird spot. Because if it's failed, we should have generated errors for contextually valid purpose or contextually valid reasons. Here, like if we didn't get an evaluator for some reason, we could say, okay, yeah, hey, we tried to evaluate this AST node and then, you know, like this is more of a generic, what the fuck, it didn't work. Okay, good. GoGoStiv says, how to live in the present moment. Oh, goodness. That's a tricky one. All right, so here's the issue with this. If I take the cast off and I let it, well, actually, this would be an F32. Just do it that way. That should work because we're not falling into that, yeah, we're not falling into that binary operator scenario. And we're falling into that binary operator scenario. See, this is not, the literal is not an F64, it's an F32. We covered this yesterday. So temporarily, because I'm not doing type widening in some of these cases, right, I have to explicitly cast it. So then the question is, okay, yes, this is technically emitting some code, but it's the first and only assignment. So then I'm thinking that we might be okay with that. So revisit after type widening in binary. So let's comment that out for now. So this should now compile and run properly because we're allowing the first assignment but not subsequent assignments, which I think semantically would fit my definition. Yeah, so that works. So we can get rid of the explicit type because we're casting anyway. But if I try to assign something else to this, this should be an error. Which it isn't. Why? Oh, no, that shouldn't be. We should be here. Oh, crap. No, yeah, I'm doing it wrong. Nah, I just see the problem now. See, this is what happens. If we're doing a constant assignment or the existing identifier's symbol is constant, then we get this error. And actually, we don't even really need that. Just, yeah. If the existing identifier we're trying to modify is constant, then that's an error. How to live in the present moment? That's a good question. Man, it's tough. Yeah, boom. Constant variables cannot be modified. Except, let's do target symbol location. I think that will be better. So there's a reason that practices like Buddhism, yeah, perfect, right? So you can't modify. Once you've assigned a constant value, you can't modify it. Try it with both a constant and non-constant assignment. Yeah, practices like Buddhism, notice that they eschew materialism, and they do that for a reason. If you have things, if you participate in modern society, and this is not a value judgment per se on modern society, it's just an observation as related to the question of how do you stay in the present moment. Modern society is very much designed to not keep you in the present moment. Because, why? Well, okay, because you're going to need a place to live. You're going to need clothes. You're going to need electricity. You're going to need internet. You're going to probably need a computer. You're going to probably need food. You're going to need, how do you get those things? Well, you need money. How do you get money? Money requires compromise. It requires economic activity. It requires future planning, right? And so there's a reason why practices like that heavily encourage you to shed as many of those burdens as you possibly can, because the more of that stuff you carry around, the more you are rooted in the current system. And the current system is, if you haven't noticed, people send you a text message and then they call you. People send you a Slack and then they call you. People send you 2 Slacks and you answer an hour later and then they get pissed off because you didn't answer them at that exact time, right? So the current world is not really geared towards facilitating that process. You can do anything you want, right? So then I would say that, Move highlights it as solve all irrational guilt that binds you to the past, solve irrational fear that binds you to the future. So let me simplify that. Learn how to find no fucks to give. That's basically what that is, right? You just have to not give a shit, ultimately. You could say this a bunch of different ways, right? Don't sweat the small stuff. But ultimately, the only way that you can really truly be in the moment is, again, if you're not overanalyzing your past and you're not, don't worry, be happy. Yeah. Although worry is a complex topic here, right? Worry involves thinking about things that happen that you can't really change, right? And worry involves you playing chess, right, into the future and trying to strategically think of things that are going to happen, and then that creates stress and it creates anxiety. But that's all extremely difficult to do, right? I mean, at least it has been for me, right? Now, I try to live in the I think I do fairly well for an American, right? For someone in the United States, if I were to give my score on a scale of 0 to 10 in terms of being able to live in the moment, I would say I'm a 5. I would say I break even, essentially. I don't really get a lot of benefit, but at the same time, I'm probably not where I was 20 years ago in my career, or 25 years ago in my career, where I was probably a 2 or a 1 if I was lucky, because I was in it, right? I was deep in it. And yeah. So I wouldn't, and again, to Move's point, don't irrationally feel guilty or berate yourself because you can't get to that state, because, it's difficult, it's complex. Yeah, it's a tricky one. One of the things I've tried to teach my kids, which it's going to take another probably 4 years with my son. I don't know. He's like me. He has to have it beat into him repeatedly. I don't know. My daughter, she might get it faster. It's hard to say. But sort of around like what Move says in terms of thoughts, and then how that becomes feelings, right? And with kids, I say they're teenagers, but young folks, and kids too, because when you start really young, right, your kid will go to a playground and steal a toy from somebody or push somebody down or whatever, right? And that's a very simplistic example of this, you know, but as you get older, it becomes more complex. And the thing that I try to teach my kids is, and it's hard to do, but where you get into the red zone, the danger zone, is when you're in something and I tell them, as soon as you start feeling an emotion, what you should do, even if it makes you look stupid, is you should just shut up, right? Just stop talking and think, right? And if you can't think, if it's really hard to think, if it's hard to focus your brain around something concrete, then that's an even stronger sign, right, that you're getting caught up. And to essentially then try to observe yourself as a dispassionate third party, right? If you were watching yourself, if you were floating above yourself and you were watching what you were doing, you know, then what would you think of that, right? What would you think of your behavior? What would you think of what you're about to say, right? And it's very difficult to do. And it creates pauses. And I've had people, like, I've been in conversations where I've done this. I'll just go silent in the middle of something because, you know, I'm recognizing that I'm having a response I don't really want, and I'm trying to figure out what's going on. It's sometimes can take time, right? And if you have to stop and say, well, oh, hold on, you know, I'm reprogramming myself at the moment. Hold on one sec. You know, they're going to stare at you even more. But I've tried to teach my kids this, and my son, you know, I've seen him do it a couple times. He's learning slowly. Let's see, would you be able to elaborate on what you mean by getting into it? Help me out. What, you know me. What was the context of what I said? Hey, Cloud Journeyman. And again, look, to Move's point earlier, you're gonna fail. You're gonna have to see your upper X. You're gonna have challenges. You can't feel guilty about it. You can't beat yourself up over it. You just have to kind of incorporate it and, you know, do your best. Not sure if Slayer Darth heard my question or not. Not sure. I know I probably said it, but I can't remember what I was saying when I said it. So I don't know how to answer the question because I forgot the context. Yeah, and that's what I was kind of trying to explain, stopping yourself in the moment. And I think some of what makes it even more difficult, like I say, at least in my case, I end up going quiet, you know, in the middle of something, and that's very socially awkward, right, in most Western cultures. And then people wonder why you're so quiet, right? And So there's, not only are you trying to prevent yourself from becoming emotional in a way you don't want, but you're also creating for other people, not intentionally, but in your efforts to control yourself, you're creating additional emotional overhead, so to speak. Yeah, it's difficult. So the biggest thing, I guess, the big takeaway in terms of living in the moment is trying to build your environment around you in such a way that it makes it as maximally possible. It didn't come out right. It makes it, gives you the maximum possible chance of achieving that goal, right? So that's about the best advice I can give, which is admittedly not that great. Okay. Super duper great. So we have one assignment for pi and for e because we have to set the constants initially, but after that we can't change them. I would say that's done. Not bad. So that replaces constant and alias. Now for alias, what? So let me go back to my short. No, not that. No. Let's say I wanted to make a J-int. I don't know. And we'll say that's a U32. So I think I'm going to have to extend the assignment code to support that. Yeah. Okay. So, all right. So everything works except the type aliasing. And I think for that, we just have to, what do I need to do there? So really, I think the implementation of that's pretty simple, right? If the right-hand side is a type, then what we're going to do is we're going to add this identifier to the identifiers map in the scope, and we're going to add this identifier as a type name. Actually, I don't think we need to even do that. I think just becomes an entry in the identifier map that points at a type. That's it. Okay. So we'll split that one off. Okay, so in our test file, I converted pi and e to constants because they are. So the constant assignment syntax is : equal. After that, we can use the constants, but we can't modify them. So we tested those cases. In the parser, I added constant assignment infix parser, which is a companion to assignment infix parser. So this is non-mutable, this is mutable. And I added in create assignment node because now we have two different parsers that are using this. So we pass in the type, right, of what node to create. based on what kind of assignment it is. Structurally, the operators work exactly the same way. They're just, one is a constant assignment, one is not. So for the constant assignment, we call create assignment node passing in that type. For the non-constant assignment, we call create assignment node without the constant assignment type. And see you later, Cloud Journeyman. Okay, and then in the AST header, I just cleaned up a bunch of these because they weren't very consistent. And yeah, these were all just cleanups, so things were consistent. And then in AST evaluator, so this is the compiler essentially, I added in the constant assignment AST node, and it calls the same handler as the mutable version. It calls assignment. In the evaluate function, I shifted one of the error messages because, yeah, we should get this error message like if we couldn't find an evaluator to do anything for us. Otherwise, we'll assume the evaluator is handling error conditions correctly for itself. In the helper function add identifier to scope, I had originally written an error check, because if we fall into this case where we have to actually generate code to do the assignment because the right hand side is not constant, that's a tricky one. So I'm leaving the code commented here for now. We'll come back and revisit this after I fix like the type widening and binary operators and some other stuff, so we don't have to do as much casting as we have to do right now. So it might, once that's kind of cleaned up, it might make sense to reinstate this check, or maybe, again, we don't really care. The first assignment, we can run whatever code we want, but once that constant has a value, you can't change it anymore. Oh yeah, so this is the actual handler for assignment. So it calls add assignments to scope, and then it needs to check whether or not success is true, because we only have something in the list if success is true. Okay, so then add assignments to scope. The AST node we get here is either an assignment node or a constant assignment node. So what we do is we check the type and we say, hey, is this a constant assignment node? Then when we go through our assignment stuff, so we're going through the left-hand side, the targets, and finding right-hand side matches, excuse me, one of the things we do is we say, okay, well, does this identifier already exist on the left-hand side, or are we creating it for the first time? So if it already exists and it's a constant, then that's bad, right? We can't reassign something that's constant. Once it's set, that's what it is. So we issue an error. Otherwise, everything else continues as normal. And then if we're creating it for the first time, we set the flag on the symbol based on whether or not we're doing a constant assignment or a regular assignment. And that is that. I remembered that this was code I commented out yesterday, because that was for the old constant stuff. Okay. Make sure that still works. Should be fine. Yep. All right. All right, I'm going to take a short break, make coffee, and I'll be back. Okay, I am back. I'm back. So that I'm going to call done. I'll be back. I do a horrible Arnold. What's the matter, Frank? CIA got you pushing too many pencils. All right. So this issue will address the type aliasing thing. So let's take a look at that. All right, so this brings up some interesting questions. Let's say we want to create an ID type, and it's a U32. So linguistically, I really need something here. We really should have like type, right? Because in a sense, yeah, because this almost acts like a cast. And interestingly enough, type of, right? Constant assignment. So I used to have that, but it was kind of violating the consistency of the language. So constant assignment, it's just a way of, it's like in Rust there's let. So if you say let foo equal 2 without a mute, right, then it's a constant, it's an immutable. This is kind of similar, it just is a constant value. So instead of having a keyword like const or constant, it just is a different kind of an assignment operator. And right now, I'm trying to think of like these. Well, you can specify type. These are variable assignments, right? So, I mean, I could say these are F32, and then I could take the cast off these. Right? So you can explicitly set types. You could make them arrays. Yeah, it's an initializer that sets the symbol as read-only once it's initialized. So after this initialization, pi is read-only. It's a constant thing. It can't be changed at runtime, right? Obviously, at metaprogram time, you could change things, but that's different. That's just it. I mean, I'm trying to limit the amount of surface area. I'm trying to avoid creating a ton of random qualifiers for things. Plus, again, this model kind of fits in syntactically. Well, no, this fits in the left to right paradigm that I'm trying to keep consistent in the language. So that's why I preferred this syntax here versus having a const or a read-only or whatever modifier. So how was no. Yeah. I like it because it's kind of visually, it's a good visual stop symbol. I mean, it really draws your attention to it. I do wish that we had, I mean, I guess if I started getting into Unicode, I could use other symbols for things, but of the languages I've seen that have done that, they don't, so I had some tasks in here around what I'm going to call compiler provided functions or intrinsics or whatever you want to call them. I guess I didn't have one for I guess I didn't add one for it. I had a line of size of So I'm guessing we should get an identifier, unknown identifier for type of here. Ooh. Okay, so yeah, it actually ended up in the right spot. So I'm trying to think of how I want to do these intrinsics or built-ins. I mean, the easiest thing to do would just be to have a map in here. There we go. Yeah, the easiest thing on procedure call would just be to have a map, and then we just look in that map first. Except yeah. So what I really need So really what I need is an initialize built-in supers. So there's two ways we could do this. Or I should say, there are two mechanisms in the interpreter that I could use here. So one mechanism is the software interrupt instruction. The other is the trap instruction. So what I'm thinking is initialize built-in procedures is going to create some kind of specialized procedure type that yeah, how am I going to do that? Yeah, so somehow we need to register a procedure type that has an identifier in the root scope of, type of, size of, a line of, whatever intrinsics we're going to build in, address of, and it'll have all the metadata around a typical procedure call, but somehow it's going to be, so either it's going to have a flag, so on procedure type, we either need to have some kind of, we already do foreign addresses for foreign function calls, but this is actually going to be an internal call to the compiler itself, or code that the compiler emits, one or the other. Hey, cache override. So in the interpreter, we have two mechanisms. One is the software interrupt. And the way the software interrupt works is there's a public interface on the interpreter. We have up to 252, I think, open slots. 254 open slots. Two of them are, or no, those are traps. So I think we have all 256 slots open for the software interrupt. And so there's a table in the heap that tells the interpreter for a given software interrupt index ID, this is the address that you're going to call. So what we would do in the compiler is when we register, so let me take a step back. So the SWI instruction is intended to call code, byte code, that's in the heap somewhere. So the idea here is that the compiler could generate fixed instruction sets, right, or fixed instruction blocks for functions like address of, size of, whatever, right? Alloc and free and anything else we need. So those blocks would always be emitted as part of any program. And I guess you could view this as like a mini kernel or a mini runtime that's built into the bytecode image. Now, none of that code is probably going to go on the native side. These would just be placeholders for the native code generation, and we would be able to map them to what we would do for, So in other words, each native code generator might have its own stand-in for that native architecture for these things, right? But this is code that actually lives and runs in the interpreter. So that's what SWI is for. There's another instruction, trap. This is meant to hook non-bytecode behavior to the bytecode system. So we have 254 open traps that we could use. We just register, there's a map that maps the index to the callable on the C++ side. And so then from within bytecode, if you have a trap instruction, so let's say you do, trap 10, right? And I don't know, let's say that maps to type of. Oh, got to change my battery. Hold on. My charger should be here today, or my power supply should be here today. It's out of customs finally. Can't wait till it gets here, and I won't have to do this anymore. Hey, Romania. Hey. So hopefully for tomorrow's program, there it goes. I won't have to swap batteries anymore. Yay. So yeah, so trap is meant as a way of allowing the runtime, the VM, to call back into C++ code without FFI, right? So this is really meant for, I mean, technically like traps are, these are things, I'm using them for like out of memory in the heap and stack overflow and things of that nature. So, where are they? Yeah, so I've got out of memory and valid FFI call. I should have stack overflow in here. So whenever the interpreter gets into a spot, right, where it needs to call back into C++ code and say, hey, something bad really happened here, or something happened, that's kind of what the intention of the trap mechanism is for. However, you know, you could also use this for, you know, kernel type behavior as well. So then the question is, you know, which way do I want to do it? I'm not sure. How do I want to do this? So I just thought of something. I'm pretty sure yeah. So what's interesting is this even has the same problem as what I originally had. Meaning like that's going to say unknown identifier. We have the same problem when we're passing it as an argument, because now here's an interesting question. That worked. Yeah, because when I create a user-defined type like this, this identifier is actually going in the identifiers list. And I think that's just a bug, honestly. Yeah, so here when we're calling, add type to scope or we're calling this numeric make types, right? And then it loops through all the metadata. And we're adding a type to scope. No, no pets. My daughter has hamsters, but no. Too many allergies. she is 12. I think. Sounds right. Remember, asking a guy who can't remember things. All right, so what I want to do here is I want to create an identifier. I don't have to do anything super complex because there's no initializer. Okay. So this should fix our deficit of valid identifiers that link to the types. Ah, okay, good. No, that's actually good. So yeah, that did fix that problem. So now our base types are actually just like a user-defined type. They're legitimate identifiers in the scope. So anywhere where you could use an identifier, you could use a type. But, I know what mistake I made. Hey, Lordborn. because we know what the type is, because it is a type. So we can just set it. T-Dog 404 says, how do you do commenting and documentation while coding? Well, first, I've never been a big believer in writing voluminous amounts of documentation as comments. And I guess I should clarify what I mean there. By the way, that fixed that problem. So we actually now have a type alias of IDT, which is U32. So that means that I should be able to do this. And I should be able to assign foo is equal to cast IDT bar. That should work. Ah, interesting. Okay. So, interesting. It allowed that, but not that. Because I bet I know why. No, this would be part of statement. So, on the question about commenting, so I think code should, as much as possible, code should read in such a way that it can be understood. Now, obviously, that's a very tall order sometimes, but it should be, right? That's what you should be striving for. You should be able to understand what the code is doing by just reading it. So, comments that say, you know, assign expression to expression, that sort of stuff is totally noise, just a waste. I don't think it serves any value. Now, if you watch me code enough, you will see that I do use comments, but they're kind of a temporary thing, right? So when I was working on the cast operator, right, I wanted to kind of condense down what the rules were. So I put some comments here. Now, this is not something that I probably would keep forever. I'll leave this here for a little while because this is still kind of open. But eventually, once this kind of gets to the point where it's where I want it to be, I would take these comments out. So these are really just more guidance for myself, and not intended for others, and not intended for posterity, right? I will leave to do comments in code if I need to remind myself to do something, or I don't want to forget about something, right? But in general, that's my code commenting philosophy. Now, no, I think that's basically my code commenting philosophy. And again, I'm always looking at the code and trying to, if I can't understand it, or it's complicated, or there's duplication, I try to clean it up and make it as readable and as friendly for habitation as possible. Documentation is a separate issue, right? There's two kinds of documentation, I guess. There's documentation that gets generated from the code. So things like Java doc, Rust doc, NDoc, whatever. You know, there's a bajillion of them out there. Again, I'm not a big fan of that because what tends to happen is you tend to get a lot of get the age from person, set the age on person, get it is. I mean, if you're going to write a tool that's going to write documentation for you, then in cases like that, it should just do it, right? It shouldn't create more busy work for you to actually comment the thing or document the thing. But in my experience, those tools tend to just create tons and tons of extra boilerplate, repetitious garbage, and just introduce more points of failure. They just introduce more locations in the code where something can be off, right? The documentation says one thing and the code says something different. I know there's a lot of people who are really fond of Rust and they actually put unit tests in their documentation and then those tests actually run. I don't know what I think of that. I mean, again, I get the idea, but there's a lot of assumptions that are going into those things, and yeah. So I don't tend to. I wouldn't use that stuff, I guess. If I wanted to do something like that, I would want to build something that does. I would want the tool to do 80% of the work, right? And then I would just want to be able to inject uniqueness wherever I need to and let it deal with all the repetition and nonsense. So that's one kind of documentation that is very common, right? Another kind of documentation would be somebody actually writing a full specification or a full introduction to their particular product, whatever it is. There's also user documentations, like if you have a tool or something that people are using. Again, the problem I find with a lot of that documentation nowadays is that it's just like, this is a toolbar. This is the cut button. This cuts things. This is the paste button. This pastes things. I mean, so you tend to get a lot of this user documentation that's just extremely high level, and it's like a parrot, right? It's telling you stuff you already know, but it allows somebody to check a checkbox off and say, oh, look, we have user documentation. I'm super old school, and, you know, my yardstick for like real documentation is what IBM produced back in the day. I think their mainframe and AS400 division still produce documentation like this, but, you know, the rest of IBM, I think, is falling down a drain quickly. But, you know, it used to be that IBM wrote volumes, and there wasn't anything you couldn't do because they told you exactly how to do it. And they told you how to handle every edge case. They told you how to handle every problem, which made the documentation very long, but very detailed. You don't tend to see that too much anymore. Yeah. So I don't know if that answers the question, but to me, if you're going to write documentation for something, like for my compiler, for my programming language, I want to write documentation for it. But I think that's a different task that requires a slightly different mental angle, and it's its own thing that deserves to be, given enough attention, right? Not just something that you try to slap on the side and say, oh, see, look, I have documentation too. So for a lot of the stuff I do, I would build the software, then I would document it. So. Was the IDT. Okay. Okay, there's our type. We got an unknown type. That's not good. Where are we getting an unknown type? You ever seen that movie Groundhog's Day? There's a scene where he's telling one of his coworkers, the woman in the story, I think her name is Rita, that he thinks he's a god because he can't die. And what he says is, or he knows all this stuff, right? Because he's been alive for, some people on the internet have actually theorized like how long this guy lives the same day over and over again. And I think the consensus is like 50 years or something. And you don't know exactly where, you know, in the timeline he's talking to her about this, but she of course doesn't believe him. So he like tells her literally all these things that are going to happen, and they happen. And there's a line in there where he calls a waitress that's going to drop a tray, and something else happens, and then she's like really surprised, like, how can you do this? And you know, I forget the exact exchange, but the main character he says something, she questions, you know, you're not a god, and the main character who's stuck in this time loop basically says, well, how do you know? I mean, maybe the real God just knows everything because he's been around forever, right? And I'm not, you know, I am not comparing myself to God. The point I'm trying to make is that the longer you do stuff, right, the longer you've been in the time loop, you develop answers for things, right? Or you develop opinions or approaches to things, and it just happens. And this is why old people are always giving younger people advice, because essentially what they're doing, or at least the way I look at it, is they're saying, God, I wish I could change that. You know, okay, I'm going to tell this youngin not to do it that way, because that caused me, you know, tons and tons of pain. And if I can convince them not to do that, then that's great, right? So now that's not to say that the answers are correct, right? Or that the wisdom is correct, you know, is correct. It just, okay, so it finds it. Yes. So type identifier is ID 105. That's an identifier. And we're going to, the type of the identifier is a U32, right? No. It's interesting. Okay, that's a problem. Okay, that's correct. I'm going to make a qualified symbol. So we're looking for IDT, fully qualified name. So I'm going to try to find it. So we do find something. No, we get an unknown type is what we get. Why are we getting an unknown type? I better know why. Yeah. Okay. So the question is, we have back in the day, right? People that you knew. You got things done. I guess that's still true today. Just the net's wider, I suppose. understand how. So find type. Oh, okay. I think I know what's going on. Yeah. Okay. So in the case where what I need to be looking at is this. This is not imparting a type here when it should be. So that's the very first assignment, right? Yeah. Well, second after the procedure. So this one should probably be print. Yeah. Format, values. Okay, here we go. Here's the type alias. So the source node, which is the right-hand side, that's a symbol. Okay. So we're going to evaluate that. The init expression is a symbol, which is U32. So we're going to make an identifier reference. Okay, so then the type gets deferred. Okay, so I gotta figure that out. Yeah, so I'm gonna have to so the issue here is the assignment code is, it's not doing the wrong thing. but it's treating this like an identifier, which it is. So that's becoming an identifier reference. The type then is deferred, so we don't know what the type of that is. Although we should know what the type of bar is, so I'm not sure why that's not right. All right, well, let's review what I have because I'm gonna have to run here. So what I'm doing now is I'm working on, for the constant assignment operator, I wanted to use this to also, the thing that I was gonna have alias do, I wanna have the constant assignment do. In other words, you can make a constant alias to any other type by just defining a constant variable to that type name. So I got part of it working, and then I was trying to test that. There's just a couple, I need to work on the assignment, add assignment to scope. I think I'm going to either need to add a special case, or I'm going to have to interrogate the identifier, like, hey, is this identifier a type? If it is, then because I bet, really quickly, I bet I could cheat this, sorta. Right? If I did that, yeah, because now the compiler knows what the type is because we're helping it. So this is a kind of a type inference bug in this scenario. I'm just curious though. Yeah, so actually this is beautiful, right? So it recognizes it, that just an alias, U32, U8. So, okay, so I gotta figure out the type inference there. Okay. In session, I added initialize built-in procedures. I may actually, because this is kind of how I wanted it to work in this case, I will be able to get this to work, but I think I'm going to have to bite the bullet here, and I'm going to have to figure out how to get these in, because we're starting to hit cases where we need them. I refactored add type to scope. It now creates a companion identifier for it. That works, and that should have been that way all along. It was just a bug that it wasn't. There was a bug in procedure call where I wasn't checking for null on the identifier. Numeric type, changed a couple things here just because I was noodling around in there. And then element builder, I refactored this method so I'm not constantly calling the getter on that. I can just get the reference once. And that was pretty much that. So yeah, I'm going to continue with that today and try to get I'll get the type aliasing working properly through the constant assignment operator. Yeah, the constant assignment operator, it's great. It does exactly what it's supposed to, and it was pretty easy to get added, so happy about that. Then I need to think about these intrinsics, like how I'm going to do it. So I'm going to spend time prototyping and thinking about that today. So not too bad. All right. Oh, that's not what I wanted. I wanted that. So we got intro PV, making a 2D platformer demake of Splatoon. We got Brooke Zerker, he's working on his Rust chatbot thing. Easy to hard lead code. Code Academy. Installing novel netware. Oh wow, that's a blast from the past. There we go. Game with OpenGL C++. Of course, I don't know how much of that's in English. Yeah, I'm actually over here slightly. 5 a.m. to 7 a.m. is really my official schedule, although I've been kind of going over slightly. Let's try this. Let's see. Can 988. All right, we're gonna raid can 988. I will be online tomorrow at 5 a.m. and we'll be working on whatever's next on the list. So making slow but steady progress. I'll see everybody tomorrow. Have a good one. Say hi to Can. And have a good one. And hopefully my continuous power will be here tomorrow. See you then. Bye.